All right. Hello and welcome everyone. Just let me share my screen again. All right. Welcome, guys. I hope all of you are doing good. Uh, and we'll begin the session for today. Now, just a quick recap of whatever we've covered, right? Uh, right before we begin the session, let's just have a quick recap of it. So, with we started with cloud computing. We saw the basics of it. Yes, we understood the different cloud models. Yes, where we saw public, private, and hybrid cloud solutions, right? Then we took a look at cloud services. Yes, that is your infrastructure as a service, platform as a service, and software as a service, right? Now, there is something else called as infrastructure as a code. You would have heard of infrastructure as a code. Now, that is a separate thing, right? Here we talk about deploying cloud infrastructure or developing cloud infrastructure by writing the code of it, right? So later on in the course, we'll quickly take a look at the ARM templates that help you do it and a brief discussion on Terraform also. Terraform is not a part of this course. I'll just let you know what Terraform is and how it works, right? So that you have an idea of infrastructure as code as well. You would have heard of it. It's almost listed in every job description that you'll find anywhere or related to Azure, right? So they will ask you to have some basic understanding of DevOps, infrastructure as a code, right? Various cloud services, either PaaS services or SaaS services, any one of them. And then we were looking at the cloud benefits, right? So we'll continue with that. We'll try to take a look at more cloud benefits, right? Because it's very important to understand. Because what will happen is later on in the course, we'll be coming across a lot of different benefits, right? For example, fault tolerance, agility, elasticity, all of these cloud benefits, you will hear about them here and there, right? We'll have some basic understanding of it. We had covered a few. We had, you know, we had the opportunity to take a look at high availability, scalability, global reach. Now, today I want to talk about fault tolerance. We'll come to agility, elasticity, and disaster recovery as well. But let's first talk about fault tolerance. Now, fault tolerance, in very simple terms, means that you're developing a system, that is able to deal with any fault that may occur, right? So you're prepared to deal with such faults. Now, faults could be in multiple forms. There could be various kinds of faults, but the ones that we, generally consider is either, let's say, internet issue, yes, electricity, yes, server going down, right? Fault with a server or fault with a, let's say, storage device, right? So various types of faults can occur. The storage device may get corrupted or damaged, similar to, servers. It may get corrupted. It may become unusable after a point. Now, Azure, and this is not just the story of Azure, this is true for any cloud service. And in fact, the first few lectures that we talk about cloud computing, they are common across all clouds. You will find infrastructure as a service, platform as a service, software as a service present in all cloud platforms, right? All cloud platforms offering these services. And obviously the cloud models also, it's common, right? It's not something specific to Azure that we are studying as of now. So whenever such fault occurs, the systems are in place to deal with them as and when the fault occurs. For example, if there is an internet related fault, the data center or the zone, yes, yesterday we discussed that a data center is called as a zone, will always have multiple options, multiple connections will be there in place. All right. Now, these multiple connections will not be from the same internet service provider. They will be from different internet service providers, so that if any one of the service provider has gone down, you will still have access to the internet through other service providers, right? The other thing, electricity, again, there are a lot of backups, a lot of electricity backups. When it comes to servers damage, right? Here, we do not replicate the servers itself, right? We do not say that, I will create 3 copies of my server. You don't do that. What you do is, whatever the service is running on this server, right? Now, a server basically provides you with storage, with CPU, with RAM, right? And on top of that, you build your services using the compute from that server or the storage from that server. Now, whatever service you've created, let's say you created a VM on this server, right? There's a virtual machine which is hosted on the server, or let's say there is an app service which has been created on the server. Any service, right, that requires compute will be created on the server itself. Now, whatever these services you've created, the service itself will give you a lot of options for fault tolerance. All right, a lot of options. For example, in the case of VM itself, we have just a second. Yeah, sorry about that. So when it comes to, let's say, the server, VM itself, right? We have a lot of options for fault tolerance. Let's say one of them is availability set, right? So here what we do is we create copies of my virtual machine to increase the availability. Similarly, there is a concept of something called as availability zone. Here also we create copies. Now, what I'm trying to do here is you're going to hear about these terms called availability set, availability zones, and then there is something called as a virtual machine scale set. All right, VMSS. Here also I am going to scale my infrastructure. This talks about horizontal scaling, right? So horizontal scaling of virtual machines based on the traffic, or the, let's say the traffic has increased, the CPU utilization, the RAM utilization, the compute utilization of my virtual machine obviously increases. And then if there is an increase above a certain limit, I will add another virtual machine into the system. And then I will be using a load balancer to balance the load across those machines. So a virtual machine scale set is also a way of increasing the availability. Now you see how many options we have available for a service itself, right? So such options will be available for various services. And when it comes to storage, now this is where you will see something very completely different. In storage, we always add redundancy, right? And there are different types of redundancy. And don't worry, whatever is written over here, availability set, availability zone, is something that we'll cover when we talk about virtual machines. We'll have a complete discussion about availability set, availability zones, and virtual machine scale sets. And when it comes to storage, we talk about redundancy, right? And based on how this data is made redundant, right? When I say how this data is made redundant, so I could introduce a form of redundancy. Let's say there is one zone or one data center in any region. If I'm creating multiple copies in that zone, this is one form of redundancy. There could be another form of redundancy where I have a region where I have multiple data centers in that region, right? Remember, if you remember yesterday, we had a discussion that a region can contain multiple data centers also. For example, the India South region that we have in Azure, it has 3 data centers present, right? So in close vicinity, you will have multiple data centers building, and that particular area is called as a region, right? So within a region, I can have multiple data centers also. So zone 1, zone 2, and let's say there is another zone 3. So one redundancy could be within the same zone, or there could be another form of redundancy where I'm saying I'll create one copy here, one copy here, and one copy here, right? So now you tell me, if I go from 1 to 2, am I increasing the availability or am I decreasing the availability? What do you think? Obviously, if I go from an option where I just have a single zone and inside that I have a single copy, and if I move towards 3 copies, then I'm increasing. But what about this situation? If I go from 3 copies in a zone to one copy each in three zones, where will I have higher availability? One or two? Please try to put your answers in the chat window. Where do you think we'll see more availability? Two? All right, great. So yes, that is absolutely correct. In option number two, we'll see more availability. And the reason is very simple, right? When you talk about increasing availability, all you have to think about is what can go wrong. If you look at a particular situation and you see that, you try to analyze what could go wrong here. And if you see there is a particular thing that could go wrong, you try to resolve that issue. If I look at option one, what could go wrong here? Here, what will happen if for some reason this entire zone has gone down? The entire data center building is down. Let's say some major electrical fault happened with the data center building and the entire data center itself has gone down. This could be the problem here. So how do I resolve it? I resolve it by replicating my data in different zones. Now, if even zone 1 has gone down, zone 2 has gone down, my data will be still accessible, right? So in option number 1, the problem that I could have faced it is what would happen if the zone has gone down. So I try to solve that issue by creating multiple copies in multiple zones, correct? Now, both the solutions, 1 and 2, whatever you saw was within a region, yes or no? Either I create three copies in the same zone or I create one copy each in three zones. We were in the same region. Let's say, for example, India South in Chennai. It has a region. We call it India South. And it has three zones like this: Z1, Z2, Z3. So first option I gave, in Z1, I create three copies versus I gave another option, Z1 one copy, Z2 one copy, Z3 one copy, right? So all of this is happening within India South region, yes or no? Do you understand now that it is all happening within the same region? What will happen if the region itself goes down? Let's say there was a disaster, there was floods or something, and the region itself has gone down. So this could go wrong here, correct? So if you try to analyze what could go wrong here after you've replicated in all the zones, then there could be a situation where the entire region has gone down. If this is going to happen, then a possible solution for it would be to have my data in region 1 and also replicate it another region 2. Yes. Now you tell me, if I go from 1 to 2, am I increasing the availability? Yes or no? Yes. And that is absolutely correct. This is what happens. And this particular phenomena is something that we call as a region pair, which we'll discuss about in the second module of the fundamentals of Azure. We'll talk about the concept of region pairs, right? So all you have to do is to increase the availability, you try to introduce redundancy. That is all. The more copies you create, your availability will increase. But then again, creating more copies does not ensure higher availability. As I said, if you compare option 1 and option 2, you can create hundreds of copies in the first case. But then again, what will happen if the region itself goes down? Correct? So the number of copies does not matter. How you're going to arrange those copies, where they are stored, what all they can, you know, what all fault they can face will decide the availability in the end. All right. Now, one more very classic example. Uh, when I say that I created one VM or a single VM, when I say that I created a single virtual machine, what does this mean? Anyone? I'll just try to reshare my screen. Just give me a second. Yeah, I hope it is visible. When I say that on the cloud, I created a single virtual machine, That means you created a single virtual machine like this. Now, how the data center is built is within the data center, let's say this is your region. Sorry, let's say this is the region. Right? And let's call it India Central. Now, again, how the data center is built is very simple. This is the region. Within the region, I will have the data center buildings, correct? So within the region, you will have a data center building like this, and you can have more data center buildings also. If you remember, we have discussed that a region can have one or more data center buildings. This is called as a zone. Within this, we'll have something called as racks. Inside a data center, what you have is called as a rack. And on these racks, you will have multiple servers placed. Do you understand this configuration? Yes or no? Everybody is aware of it? Let me just show it to you. Let me try and show it to you of what the arrangement would look like. Let me just find a picture of it. I have it. Yeah. So this is what a data center building looks like from outside. All right. So you can have multiple data centers within this region. So this is one of the data centers which is present in Dublin, Ireland, right? Azure Data Center. And this is what it looks like from inside. All right. So these are all racks. Rack 1, rack 2, right? Similarly, rack 3 here, rack 4. And what is present on these racks? Servers are stacked one on another inside these racks. Clear? So a simple arrangement, if I want to draw, will be a rack like this within the data center, having servers kept on those racks like this. Correct? Now, what means here is that if I say one single VM, that means I have to create a single racks, and the Y means number of servers. All right, here X comma Y means number of racks and number of servers. Now, what this exactly means is how many copies do you see on the screen that I've created? How many copies do you see? We've created 7 copies. And how many racks have we used to place them? On 3 racks. So 1, 2, 3, 4, 5, 6, and 7th copy here placed on rack 1, 2, 3. Correct? So my set here would become 3, comma 7. Why? 3 is the number of racks, X, and Y is number of servers, right? So I have 7 copies present on 7 servers. So this availability set is 3, comma 7. Is that clear? Now, within a data center, all of you may have heard about data centers. Within a data center, how many racks do you think are there in general? Can you guess? So there will be hundreds of racks, right? If it's a very big data center, there will be thousands of racks also, correct? Thousands of racks, hundreds of racks, or thousands of servers. A data center is a big unit, correct? So therefore, hundreds of racks, thousands of servers are there. So can I create thousands of copies of my virtual machine? Yes or no? Can I create endless number of copies? Absolutely not. So here we have a maximum limit of x and y. We have defined that the maximum number of racks that you can select to create these copies within an availability set. When you're creating an availability set, within that, the number of racks that you can select is 3, and the maximum number of servers 20. So the biggest set that I can create is 3 comma 20. That means on 3 racks I have created 20 copies. Clear? This is the concept of availability set. So by adding redundancy, we are increasing the availability. We're trying to increase the availability with redundancy. Is that clear to everybody? All right. Now, when you go to storage account, now here again, you add redundancy by creating copies of your data, right? And when we talk about storage account, when I show you the storage account in Azure, right? And it is true for databases also. In Azure, when you create a database, or in Azure, when you create a storage account, the different types of redundancy that you will see are something called as LRS. One second. Second is ZRS. Third is GRS. And the final one is GZRS. LRS stands for locally redundant storage. ZRS stands for zone redundant storage. GRS stands for geo redundant storage. And GZRS stands for geo zone redundant storage. All right. And whenever you're creating a storage account, whenever you're creating a data lake, whenever you're creating a database within Azure, you have to decide on one of these redundancies. It is mandatory. You can never create a single copy of your data. Single copy never allowed. It has to be at least a LRS. All right. And the redundancy options that I've shown you, these are in hierarchy. All right. So lowest redundancy to highest redundancy. Clear? Now, how LRS works is very simple. Same data center, create 3 copies. ZRS means zone redundant storage. So now we have to create copies in the multiple zones of the region. So if in a region I have 3 zones, zone 1, zone 2, zone 3, and these are all the data centers within the same region. All right, this will not be a multi-region setup. I create 1 copy here, 1 copy here, and 1 copy here. And then you have GRS, the geo redundant storage, where I say in one region, I will have 1 copy, and in the region pair, I will have another copy. So different regions altogether. So this is, let's say, India South. This will be India Central. All right, so in multiple, and here everything will happen in India South only. This is also India South. This is also India South. Same region. LRS, ZRS in the same region. GRS, geo redundant. So now you are creating it in multiple geographical locations. So region 1 and region 2. I create 2 copies. And then you have a sum of GRS plus ZRS is your GZRS. Very simple. Within region 1, I have multiple zones. Let's say this is India Central. And within the other region, I have multiple data centers again. Let's say this is India South. So sum of GRS and ZRS will mean that I create three copies in three zones here and three copies in three zones here. Is this clear? The multiple types of redundancies that you have with the storage account? Yes or no? Everyone. So these are some of the methods of fault tolerance that you implement, and they basically relate to creating redundant copies of your data, right? Because eventually it all comes down to whether we are ensuring the highest form of availability or not, right? And the highest form of availability can only be achieved when we can be 100% sure that nothing is going to happen to the data, even if the data center goes down, even if the racks have gone down, even if the region has gone down, we still have your back, right? Your data is safe with us. So that is why these organizations, they try to organizations, not organizations, but cloud service providers, they introduce such methods, such options available to you as a customer, as a consumer, to increase the availability of your data. Clear? All right. Now we'll stop discussing about the basics of cloud. It's a demo session going on, and I wanted to touch upon a very some advanced topics also now, such as your Azure Data Factory. All right. So how many of you heard of Azure Data Factory? Ever heard of it? Yes. Yeah, you may have heard of it. It's a very famous service. Some of you may have worked also. Yes, absolutely. Yeah, so ADF, we generally use the term ADF for Azure Data Factory. Yes, and it's a cloud-based data integration service, right? Data integration means, you know, collecting data, getting data, extracting data. Yes, and it helps you with data movement and data transformation. You can orchestrate, right, the entire data movement and the data transformation process by creating these pipelines that you create here. All right. Now you create these pipelines. It's a very simple thing, right? A pipeline will just look like this, right? Simple pipeline that you've created. It will have a source, it will have a destination, and it will have some activities here, right? Very simple. Only these three terms are there, nothing else. Source, destination, activities. All right. If you've understood these three things, you've understood how a pipeline works or how Azure Data Factory also works, right? Obviously, there are other concepts also within Data Factory that we need to cover first. But source, in very simple terms, is basically your source data, right? Let's say my source data is a CSV file, right? Now, what I'm going to do when this pipeline will run, right? And this pipeline will run automatically. You can either you can trigger it manually also. You can automate this process also. This entire pipeline will help me, first of all, ingest the data. Yes. The second, transform the data, right? Prepare and transform. And then finally, I can put the data to the destination. All right. To load the data in the destination that is there. Right. So Data Factory is designed to handle complex data integration scenarios, right? Now, it not only works with cloud-based services, it can also ingest your data from on-premise environment, yes, process it, put it on the cloud, or it can get data from a cloud-based store, data store, process it, and then put it in the on-premise environment. It can connect to either on-premise also, and it's a cloud-based services. Obviously, cloud connectivity will be there. Clear? Now, these three things here, what you say, are called as your artifacts. Within Data Factory, these artifacts are first the pipeline itself that you will create. The second, not directly, but source data contains a couple of artifacts. So I'll just write source data here and I'll explain the artifacts that build up this source data. Yes. And similar for destination data also, you will have two artifacts here. Something like this. Then you have activities. All right. So you have the pipeline, you have the activities, and then you have something called as an integration runtime. Yes. And then if you want to consider, you can consider triggers also. Right? Multiple types of triggers are there: schedule triggers, tumbling window triggers, storage event triggers. We'll talk about all of them. Now, this is what makes your Azure Data Factory. All right.
What about Shreyas, what about data flow?
Data flow is also a part of it. Yes.
Okay.
Data flow is also a part of it. But how we cover it, we cover the basic data factory first. And then when we go to the advanced features, that is where we talk about data flow
Okay.
as well as mapping data flow.
Okay. Thank you.
That is also there. You're absolutely correct. It should also be considered here in the artifacts only. All right. But these are some of the advanced features, right? Data flow and mapping data flow will help you to perform more complex transformation. They will give you a UI, correct? They will give you a drag and drops, canvas where you can create or you can, visually design your data transformation through data flows, correct? Now,
is it a part of activities? I guess data flow.
yes, data flow is an activity, right? You're absolutely correct. So data flow you define separately, but within the pipeline, it will work as an activity, right? So I'll not, there are few people who are new to Data Factory, so that is why I'm not, integrating this as of now with them, right? As it is, we have 5 topics here where the source data and destination data will together give you 2 more artifacts. Can you name them? What do I need to connect to the source data? Yeah. What do I need to connect to the source data and the destination data? First of all, I need something called as a
linked service.
linked service. Correct. And when I'm defining the source data and the destination data using the link service, I define something called as a data set also.
Yeah.
Correct?
Yeah.
So pipeline, link service, data set, activities, integration runtimes, triggers, and data flows also. They're all your artifacts within Data Factory, right? Artifacts basically mean the components. All right. Now you don't have to worry about all of these terms. They're all very simple to understand, right? Pipeline is a combination of link service, data set, activities, integration runtime, and trigger. So this pipeline is nothing but a sum of everything else that you see. All right. So now let's break this down. Let's start one by one. Source data. Now, whenever I want to create a pipeline, right? So basically what I'm trying to do is I'm trying to ingest the data, transform it, right? That is my objective here. I need to get the data from the data store first, right? The source data has to be fetched, correct? Now let's say This is my pipeline here. I've created a pipeline. Now for this pipeline, to be able to connect to the source data store. Now data store, let's say in my case, is a data lake. Now I will quickly explain to you. Obviously, when we cover data factory, we would have covered data lake already. But data lake is a cloud-based data storage service. It's an Azure cloud data storage service. It is built on top of your storage account. This is where all your raw data will come and sit. All right. So generally, whatever raw data that we collect from various places, if I want to do transformation, if I want to do data analysis, right? First thing is to collect data. Now, when I start collecting data, I will store all of that collected data into a data lake. Clear? Once my data is present here in the data lake, I need to access that data from my pipeline. Yes or no? Yes. I need to get that data into the pipeline. How do I get that data? Now, any data store, I will need an authenticated mechanism to get the data. This data store is known for its security, whether it is a data lake or let's say it's a database, it's a SQL database. They're all known for their security. Will they give data to anybody like this? What do you think? Any pipeline asks for data, is the data store going to give that data away? No, it does not. There has to be an authenticated mechanism in place to fetch that data. And that is what a linked service does. The link service will contain the address of the data store along with the credentials. So now when I have the address and the credentials, can I connect from this pipeline to this data lake and ask for data? The answer is yes. First of all, I need to know the address. So the link service will only contain two things. Always remember, it will only contain two things. One is the address along with the credentials to authenticate onto that address. Right? Yes or no? Do you understand this? Very simple terms. From any pipeline that I create, it could be any pipeline, right? If I want to connect to any data store, a SQL database, do you authenticate onto it using the username and password if you've selected SQL authentication? Yes? You need to authenticate on the SQL server using the username and the password. That is also authentication. So if I create a link service to connect to the database, that will first contain the address of the server, right? Whatever the server URL is, that, sorry, URL along with username along with password. So a link service helps you to connect to a data store. When I say a data store, it could be anything, the source or the destination. Is this clear to everybody? A data store could be a source of my data, or it could be the destination of my data also, where I want to post this data after the processing has been done, because we've not discussed data factory in depth because it's a demo class, right? But data factory only gives you data movement and data transformation feature. This does not work as a data storage service. There is no storage capacity with data factory. Data factory cannot store data. Please keep this in mind. It is only a tool that is going to ingest the data, transform the data, and then post the data to whatever destination you have defined. To ingest the data, I will need to connect to the source data store. To post the data or to put the data, to load the data in the destination, I will again need to connect to the destination data store. All right. And this connection that I'm going to do from my pipeline to any data store will be done through a link service. Is this clear? Now, if there are multiple databases, database 1, database 2. How many link services will I need?
One per
How many link
database.
services?
One per database.
One per database. Absolutely correct. If I have multiple data lakes, again, I will need a link service for this and a link services for this also. Why? Because the link service contains the address. The moment I change the data lake, the address changes and hopefully the credentials also change. Right? Because everybody will have a different credential for a different database or a different data lake, or the data store could be anything. It could be a data warehouse also. It could be, Amazon storage also. You can connect to other cloud storages also. And then it could be your on-premise also if I want to connect to on-premise, right? So a link service is used to connect to a data store. It will contain the address and the credential which is required for the pipeline to authenticate onto this data store and then ask for permission. So basically what I'm doing by passing the credential, I'm just taking their permission to connect to them and take the data, right? So that is your link service. Now, when you start, so you're talking about source data, right? The moment you start defining the source data, right? Now within ADF, you have to tell them what data you are transferring. Yes or no? I need to tell ADF that these are the files that you need to fetch. These are the files that you want to ingest. Correct? Once I have the link service in the place, that means from my pipeline, if this is my pipeline, I am now connected to my data lake, right? So this connection is now successful because I have the link service in place. Correct? What other information do I need to give?
What kind of data?
What kind of data? Absolutely correct. So within my data lake, now I don't want to confuse you as of now, but within the data lake, you will not have the data directly. You will have something called as a container, right? So within the container, you have the data, right? So within the container, let's say you have a file which is of the type CSV. Let's call it xyz.csv. This is my file name. So then I need to tell ADF that the link service has helped me to connect to the data lake. Now what else? I need to add information about the container. Yes or no? Where, in which
It-
container you have to look for the data?
Is a
Then,
container is also called blob storage or something?
uh, see,
Blob storage.
yes, we call them blob storage because essentially what data you put inside a container is the blob data. Yes,
Okay.
you don't keep structured data within a storage account, right?
Yeah.
So what you keep is binary large objects, the files which are present in the binary format. So we'll come to that later on when we talk about Azure storage. We'll have a complete in-depth discussion on that.
Okay.
So this container, also called as blob storage, absolutely correct. Along with that, I need to first give the file details, such as the name of the file. Then I need to give details such as the type of the file. Yes. Now type of file will mean it's a CSV file. What is the delimiter? Comma is a delimiter. What is the line break? All of that details I need to give. So now you understand, just connecting to the storage account wasn't enough. I need to give the container details. Need to give the file name that you have to pick, right? I need to also tell you the type of that file. If it's a Parquet based file, right? So this is a compressed form. Then again, I need to define what format it is. It's a Parquet format, and Parquet format basically to compress and decompress the file, we use something called as a snappy codec. All right. So snappy codec is a tool that helps us to compress or decompress these Parquet files. I will not get into that depth as of now. But that also I need to mention that use snappy codec to compress or decompress this file. So I am seeing that apart from just mentioning the link service, that is just the ability to connect to the data lake, I also need other information to successfully define the complete source data. Yes or no? If I just give the link service, that does not define the data, source data. because link service will only take me as far as the data lake. It will put me within the data lake. It will allow me the entry within the data lake. Within the data lake, where is my file? What is the name of the file? What is the type of the file? Right? All of that details also I need. This together with the link service, these details along with the link service becomes your data set. Source data set in this case. And same thing for destination, where you connect to the destination using the link service, and you define how your data will be stored in the destination, what format it will be stored, which container it will be stored, what will be the file name in the destination where your data will be stored. That becomes your destination data set. Is this clear to everybody? The difference between link service and data set? So a data set will consist link service, and link service it's in itself will just let you connect to the data store. Clear? Yes or no? All right. Now, activities are basically the transformations that you define on the data. All right. Or let's say within a pipeline, if this is your pipeline, right? Something like this. There will be multiple transformations that you will be doing on the data, right? So let's say first step would be uh, to bring the data to a unified format, right? So this is the first step. Then on the same data, you need to perform a second step, let's say removing the null values. Then the third step would be, let's say, uh, filtering some of the data, or let's say removing some of the unwanted columns. Correct. So within the pipeline, all these different stages are there, different steps are there. Yes. Let's say within the pipeline, towards the end, I want to copy the data also from one place to the other, right? If that is also required, let's say the final data that you have in the pipeline, you want to copy it also somewhere. So all this movement related activities, transformation related activities, control related activities are basically the steps that you are going to perform on the data within a pipeline. Is that clear to everybody? All right. So these activities are nothing but the individual steps within the pipeline, right? So as somebody said, data flow. Data flow is also an activity. All right. Once you define the data flow, you are going to place it within the pipeline as an activity. So that data flow activity will be completed. Similarly, copy data activity, transformation related activity, filtering, right? Aggregation activities, all of that is available. And the final thing that we wanted to discuss was integration runtime. Now, integration runtime, or sometimes we also call it Azure Integration Runtime, right? AIR. Within Data Factory, when you look at it, it will be called as Auto Resolve Integration Runtime. All right. So there are three names to it. We generally call it integration runtime. Sometimes we also refer it to as the Azure Integration Runtime. But when you look at it within the Data Factory, you will always find the name Auto Resolve Integration Runtime. All right. All three mean the same thing. Integration runtime is basically the compute infrastructure. Now, when you're doing so much of transformation, when you're moving data from one place to the other, or doing some other activities like filtering, aggregation, copying it to some other place, all of this requires compute. All of this will require some compute power. Yes or no? If I do not have some processing power, how am I going to process this data? So therefore, processing power is required. And within Azure, or within Azure Data Factory, I would say, this processing power comes from the integration runtime. This integration runtime is the compute infrastructure that is created. All right. my data factory uses this auto resolve integration runtime, which is basically the compute infrastructure. This will have certain amounts of CPU. This will give you certain amount of RAM to process your data. Storage service is not there. All right. And it's very simple to understand. To process the data, I need some processing power. So where am I going to get this processing power from? I'm going to get it from the integration runtime. All right. Because, and this is pretty different from other services. For example, any other service that you create within Azure, you will have the ability to select the compute. You will have the ability to define the compute as to how much compute I want. All right. But within Azure Data Factory, you don't get to decide the compute. All right. Compute is managed by Microsoft here or managed by Azure. When using Azure integration runtime, I have no control over how much compute will be provisioned for my pipeline. Azure will take care of it. If more compute is required, Azure will add more compute. If less compute is required, it will process it with less compute. Is that clear? Yes or no? So in very basic terms, that is your integration runtime. Now, when we talk about integration runtime in depth, then we'll see how it basically is provisioned, what are the alternatives to the integration runtime. So basically in Azure, there are, in Data Factory, there are three types of integration runtime. One is your Azure integration runtime, the default one. Then there is something called as a self-hosted integration runtime, and then you have Azure SSIS integration runtime. All right. And then finally, you have something called as a trigger for a pipeline, and this trigger will determine when the pipeline execution will be initiated. All right. So you can have a manual trigger to a pipeline, right? Basically triggering the pipeline as and when you want to trigger it, right? Secondly, you can have a time-based trigger. You can define a schedule for trigger, right? Like every hour, every 30 minutes, or every 24 hours, this pipeline should automatically run, fetch data, process it, put it in the destination, something like that. All right. Or you can even have an event-based trigger, like, for example, run the pipeline whenever there is a new file which gets added to my storage account. All right. And pipelines, I don't think we discussed a lot on pipelines. Why pipelines? Why, in modern age, everybody wants to use pipelines. So there's a lot of a lot of depth into the reasons as to why, we are preferring pipelines over writing your scripts, right? Generally, we used to write scripts for data movement and all, but now we are preferring pipelines, right? Because pipelines are built for modern architectures. Pipelines are designed, right, to work seamlessly with your modern cloud platforms such as your Azure, AWS, Google Cloud, and even your distributed systems, right? And pipelines, they also natively, right, support scalability, elasticity, and this integration with the modern tools that you have. And it's a low code, no code approach, right? Pipelines will often use a visual drag and drop interface, which reduces the need for deep programming expertise. Anybody, right, even you and I, who have no experience of coding, can come and create a data movement and data transformation pipeline without knowing any programming language, right? It's not required. So it's good for people who don't have a very strong programming expertise, I would say. And again, right, when you are writing code for data movement and data transformation, with the time that code will become obsolete. Yes, there will come a time when that code becomes obsolete, and that is where we talk about this code modernization, process modernization, application modernization, because those applications were written using legacy codes, older versions of the code. With pipelines, you don't have to do that. With pipelines, you just define the logic through a visual interface. The rest, eventually when you create a copy data activity, this activity you create on the portal, it is going to copy data from one place to the other, right? It will move data. But in the backend, everywhere, code will be there. Some code will be executed in the backend, right? But the benefit of pipeline is that you don't have to worry about this code or this code becoming obsolete. Microsoft will take care of it. Is that clear to everybody? And these data sets you create, these link services you create, they're all reusable, right? You can reuse them with different pipelines. So guys, with that, we'll stop the session here. I hope all of you had a good time. We had a brief discussion on Data Factory. Obviously, when we continue with the course, we're going to have a lot in more depth discussion about Data Factory. Yes, we'll see a lot more features and a lot more demos also. Uh, I wanted to show you a demo today, but again, then we have, there's a shortage of time. But I hope that all of you, yes, I hope to see you guys tomorrow in the class. And from tomorrow onwards, the paid session will start. And you can get in touch with the backend team to inquire more about that. And you can get in touch with them also to register for the course. So again, I hope to see everybody, right? We have some good amount of people here present. So I would request everybody to be a part of this course, to join us. And again, I'll see you guys tomorrow. And from tomorrow onwards, as I said, we'll have the paid session starting. So for any clarification, any doubts you may have, you can contact the backend team. Yes, the contact number is in the chat. You can talk to them. And yeah, that's pretty much it. So thank you guys.
Yeah,
It was a pleasure having
Shreyas,
everybody.
I
Yeah.
have a question. I have little bit background on ADF, but no background on the Databricks. Databricks is also similar to this to learn, or it is a little bit difficult?
Not really. Databricks requires coding.
Oh, okay, data.
You
Okay.
can create pipeline there also, but eventually we use it for with PySpark, right? Creating notebooks. Um, and there's a lot of things within Databricks actually, right? So
Yeah.
again, we'll be covering everything within Databricks. And as I said, SQL is the only prerequisite that I want everybody or from everybody to have, right? That is something that I cannot teach you in this class. SQL I'm not going to teach obviously, but that is required. SQL is required. So if you have good amount of SQL knowledge, you can do that. Even if you don't have SQL knowledge, it does not take a lot of time, because eventually in the beginning we'll be covering the basics of Azure, and that time is more than enough for you to become experts on SQL, right? So basic level expertise or intermediate level expertise on SQL is something that I request everybody to have. And Python is something which I want everybody to learn eventually, right? Even if you don't know Python today, it's fine. But eventually, to become a good data engineer, you need to know Python, right? So that also, I request everybody.
Small doubt.
Yeah, go ahead.
Okay.
Ask.
So yeah. I have I have no 12 years of experience, including non-IT, and relevant IT experience is 8 years. So for last 3 years, I'm working in an MNC company. Okay. So my only option to get a job in as a data engineer is I have to say I'm working in as a data engineer for last 5 or 3 years, like that, right? When I try for a job.
Yeah, you can
So
add some bit of experience.
yeah, my doubt is when the course gets completed, will I get enough knowledge on the for that experience, 3 to 5 years of experience
Yes, absolutely. You
to
will
attend
have
the
a good
interview?
in-depth. See, eventually you will have good in-depth knowledge about various Azure services, right? And the kind of questions that they ask in exams, that also will cover. But then again, as I said, see, SQL is something that you need to know, and Python is something that you need to learn, right? And apart from that, everything, every major concept, we are going to cover it in depth. And yes, as I said, you will be working on a couple of projects also. So that will also add to it. And yes, we'll be helping you in updating your CVs as well. We'll be sharing some sample resumes with you, which you can, add the experience you can add to your profile as well.
Okay, so we will be getting support till we get a job, or once the course completed and resume preparation is done, we have to clear the interviews on our own. If you go
Yes,
for if I go for
as I
interview, if
said,
I
so this course will last for more than 35 days, right? We'll be covering all the topics, basics to advanced level in Azure. So knowledge will be there. The resume support we will give you. The recently asked interview questions from various topic-wise questions we have. We'll be sharing that as well with you. So I think that will be more than sufficient to prepare you, right, uh, for an interview or for a job in Azure Data Engineering.
Okay, thank you.
Shreyas, Yashwant here.
Yeah, hi Yashwant.
Yeah, can you able to provide the contents for Python? Like, what are the things that we need to cover as part of Python? We'll get to know, right?
Yes, absolutely. So see, couple of things. Resources with PySpark. I'll be sharing it with you. Python,
Okay,
I can refer to you. I can refer you some good learning material available on YouTube, which you can watch,
okay,
and we'll be sharing it
okay.
with you, obviously, which you can watch to start with the basics. But as I said, right, the more and more you learn, the better you get. So that you
Only
have to.
basics are enough, or do we need to go ahead
Basics
with
are
OOPS
enough.
concepts as well?
No, no, not required. See, basically the different libraries, right? The mathematics libraries and all of that, if you know. And eventually, what we want to learn is PySpark, right? PySpark programming.
Okay.
And for that,
Yeah,
I will be sharing multiple resources with you, which can help you to become, really good PySpark developers. So you don't have to worry about it.
okay, okay. Thanks, Shreyas.
Yeah. And we'll be doing a lot of demos on PySpark also in the class, right? We'll be taking a look at all different various activities from, reading data to writing data to various different types of transformation, string transformation, rows, all those things we'll be seeing in the class itself. So most of it you will see in the class, but then again, as I said, the more you practice, the better you get. That you have to
Yeah,
do. Yeah.
okay.
All right.
Hi, Shreyas. This is Suresh from Chennai. I
Yeah.
have
Hi,
some
Suresh.
doubts. Yeah, for practice means we can practice because I have already tried in Azure free accounts, some of free accounts. After that, if I have to create means it's you are not eligible for the free accounts. So please go pay as you go like that. If I have to
Mhm.
practice means how can I practice? Is there any platform you have to provide to us?
Yeah. So the labs will be provided. As I said, you will have labs from Scalable. I'll just quickly show it to you what all lab topics you can expect.
Okay,
Uh,
please. Because that was more challenging for us for
no,
practice.
for data engineering exercises, we have these labs. All of these labs will be made available to you. All right. Explore Synapse, query files using serverless SQL pool within Synapse, transform data using serverless SQL pool, and then transform data using Spark in Synapse. Use Delta Lake in Synapse. Load data into a relational data warehouse. Build a data pipeline in Azure Synapse Analytics itself. Use an Apache Spark notebook in pipeline, use Azure Synapse Link for Azure Cosmos DB, right? Ingest real-time data with Azure Stream Analytics. So Stream Analytics labs are there. Use Microsoft Purview with Azure Synapse Analytics. That also a lab is available to you. So whatever you see within a lab, right? All these steps, you will get an environment to practice all of this. All right. So a lab is basically going to
Okay,
contain multiple steps, right? So first of all, provision the resources, explore your Synapse, create a lake database, add and configure a Microsoft Purview service account. All of this you will be able to do within the lab itself. And each lab will come with 10 attempts, and there are around a total of 22 labs available. So that hands-on
okay,
we'll provide, and then we'll see how we can support you to get another Azure free account.
okay.
All right.
So, and one more doubt, in the entire course will be conducted by yourself or in some other
Yes,
trainers
I,
also will
I'll
be,
be I'll be conducting the entire course.
okay,
All right. And whatever we've covered until now, don't worry, from tomorrow we'll start again. These were the demo classes. I'll consider that, until the cloud benefits that we've known, you've been there. But then again, we'll just touch upon those topics once again because that is going to be the first class. And I don't want to, start from where we left. I want to start from scratch from the first class itself. So whatever we covered in the past 2 days, we'll quickly start with them. All right.
okay, that is far better.
I was just skeptical that 35 days will be enough to cover Synapse, Azure Data Factory, and Databricks in depth.
Yes, yes, absolutely. So see, I say 35, but it's 35 plus. So we generally go to around 40 classes, 40, 41, depending on, see, it eventually depends on how the class responds, right? So the more interactive you guys are in class, the more questions you ask, the longer the course duration will be. All right.
Okay.
That is something that I have noticed in my 10 years of teaching. The more interactive class, the longer the class duration is. More silent the class is, faster it gets completed. So that interactivity, all of you have to drive from your end, right? You have to keep on asking questions. Whatever you do not understand, I do not mind explaining it to you again and again and again, right?
Yeah. And regarding the interviews, if they ask us to explain the projects and also will we
Yeah, so
be
you will be working on the projects. You will be implementing 2 projects on your own.
okay?
Yeah.
Thank you.
Slash Anish here. Actually, final question here. We can go for the certification, right? With this Microsoft certification.
See, Microsoft DP203 certification, they are going to discontinue in March, right? So the reason is very simple. They have recently launched a new tool called Fabric. So I don't know how many of you heard of it, right? So they've recently launched it, and they are trying to market it. Currently all the organizations are relying on whatever the current technology is. They will be working with it, but then Microsoft wants to, integrate Fabric as well. We'll have a brief discussion on Fabric as well. But as a long time or a long term goal in their mind, right? They want to integrate, or they want to make organizations add Fabric as well into their data engineering workflows. So what they are doing is they're going to get rid of the DP203 certification, and they're going to launch another certification with Fabric in it. All right. And that will be termed as DP700. It's already been launched.
Yes, yes. Um, this is Nagi. I have a question regarding Fabric. Can you please give an overall idea what is Fabric? Because even in Power BI, if we work on it, we see like Fabric popping up.
Yes. So see, we'll discuss about it. We'll have a couple of session on fabrics, right? We'll try to explain. So basically, it's how they did with warehouse, right? Earlier we had data warehouse, we had serverless SQL pool separately, and they brought everything under one umbrella of Azure Synapse, right? So basically, earlier data warehouse was a separate service, a SQL data warehouse within Azure, and serverless SQL pool, Spark pool, they were all different services. So they brought all of them together under the Synapse family. Similarly, what they've done now is they brought everything together within a single Fabrics family, right? So it has nothing to do with Azure portal. Fabric is not available on Azure. It's a different Microsoft product itself, right? So even if you go to the website, it's fabric.microsoft.com, the portal. So I'll explain it to you. Whatever you can do here, warehousing, uh, data lake, right? Delta lake, all of that you can prepare in Fabric also. Even your data factory is present in Fabric. We'll discuss about it. I'll give you an idea as to what it is.
Okay, thank you.
Yeah.
I have one question.
Yeah.
We will learn the Spark streaming as well on the Databricks.
We'll be working with the streaming data source as well on Spark.
And the Azure account, will you provide us, or do we need to create by our
The
side?
labs I will provide. The free Azure account, I will guide you how to create it.
But I think it is valid for some days, and after that it will
Yes.
expire. Then
It comes with
what we
a
need to do?
$200 credit for 30 days. Yes.
Then what if the account expired because the course will long last maybe more than 30 days?
Yeah. So we have the option of Azure passes also available, right? But then I think that is a paid service. You'll have to pay for the Azure pass. right? So there also you'll get around, I think for $30 you can get $200 worth of credit, which is valid for, I think, 6 months.
Okay.
Yeah.
Okay. Thank you.
So if you need, we can provide you with Azure Pass as well. The labs are free with the course. Yes. All right
Actually,
then.
I'm facing
Yeah.
a
Yeah. Yeah. Go
little
ahead.
problem with the payment. So I will contact with your backend team.
Yeah. Yeah. Sure. They've shared the number in the chat window. You can contact them.
Okay. Okay. Perfect. Thank you.
Hi, Shreyesh.
Yeah.
So can I access that portal in USA also?
Yes, that portal is accessible everywhere.
Okay.
Yeah.
Okay. Thank you.
All right then. So with that, we'll close today's session. Thank you, everyone. It was a pleasure having all of you with us here today. And as I said, I hope to see you guys tomorrow. But thanks for being here and making this a couple of days demo session interactive and being here. Thanks for your time, guys. Thanks a lot.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks, Reyes.